All right, last section of Unit 4, which means we have a test coming up. We're talking synthetic division and the factor theorem. So we've already done synthetic substitution, and you can read here if you want what synthetic division is. It's basically the same process, it's just that our answer means something different. So, the setup. Make our L. We're going to use whatever we're trying to divide here. It's this polynomial in this example. We'll use the coefficients there to put inside our L. So we'll go 1, -1, -2, and 8. And again, if you're missing any terms, you would need to put a 0 there, but we have x cubed squared to the first and 0 back here, so we're good. No zeros needed. And then the other thing here, so you can't just use x minus 1 and put it out here. You're not going to want to. That's essentially long division and much more difficult. So what we're going to do, whatever we're dividing by, x minus 1, in this case, we're going to take that, set it equal to 0, and solve for 1. So we're going to put a 1 on the outside, or solve for x, we get 1. So that's what we're going to use on the outside. So just like synthetic substitution, we'll drop the first number down. We'll multiply the numbers on the outside. Then we'll add, so -1 plus 1 is 0. 1 times 0 is 0. -2 plus 0 is -2. And -2 times 1 is -2. So we end up with a 6 there at the end. Now, with synthetic substitution, 6 would have been our answer. But this is not synthetic substitution. This is synthetic division. So what we are doing is we're trying to divide this polynomial down into something that we can work a little more efficiently with. So here's what our answer is going to look like. What we have here are coefficients of our new polynomial. I'll talk about this number in a second. So we have coefficients of our new polynomial. So we started with an x to the third, which means our new polynomial, because we divided, is now going to be a 1 x to the second. So we went down 1 degree, plus 0x from right here, minus 2 from right here. And so you're probably wondering, what is this 6 that's left over? Well, that's what we're going to call our remainder. So we're going to go plus 6 over, and then whatever we divided by. In this case, x minus 1. So yeah, we're back to remainders. So if you want to clean this up, which I would suggest doing, you actually get x squared minus 2. So we don't need this term. And we don't really need the 1. Plus 6 over x minus 1. And there you go. That is synthetic division. That would be your answer. Like I said, it's the same process. Your answer just looks different. So let's do another one here. So the setup, we'll go 2, -9, -32, -21. And then again, take what you're dividing by, x minus 7, set it equal to 0. And you get x equals 7. So 7 is going on the outside here. Oops. 7 on the outside. We'll drop our first number down, 2. Okay, 2 times 7 is 14. If we add them up, -9 plus 14 is 5. 7 times 5 is 35. Add them up, we get 3. 3 times 7 is 21. And 21 plus -21 is 0. So what we have now is a new polynomial. So we started with a third degree, so now this is going to be a second degree. So 2x squared plus 5x plus 3. Now, if your remainder is 0, you don't have, like we had this part right here, we don't have that anymore. It would be plus 0 over x minus 7, but that doesn't make any sense, so we don't need it. So we actually have a nice polynomial left over, which leads us to the factor theorem. If my remainder is 0, which it just was, then whatever you divide it by is a factor of the polynomial. So that means that x minus 7 is a factor of this beast right here. Okay? Which means that 7 would be one of your answers. So let's try another example really quickly. So here we go. We'll go 2, -7, -1, -12, and you could probably do the math in your head and find out that x is going to equal to 4. But here it is again. Add 4. Wow, I got 4. Okay. So I'm going to drop this down. 2 times 4 is 8. Add them up. -7 plus 8 is 1. Multiply them, you get 4. -1 plus 4 is 3. 3 times 4 is 12. So we got a remainder of 0, which means that x minus 4 is a factor. So we spent the last section and sections before in previous units factoring. By grouping was the last one, or the box method, the A times C thing. Different ways to factor, greatest common factor. But what this does too is it tells us now if your remainder is 0 that x minus 4 is a factor. Now what's left over after you factor that out is what's made up of these numbers right here. So we'll go 2x squared plus 1x, but again, you don't need the 1, so I'm just going to go plus x plus 3. That's what's left over. So yeah, I mean, solving polynomials with synthetic division, solve the polynomial function. So this is kind of the final stage of synthetic division and synthetic substitution. So it says to solve the polynomial given that x equals -4. So what they're telling you here is that -4 is one of the answers. Okay, so let's do 3, 13, 2, -8, and -4 is one of the answers. So we're going to use synthetic division, drop to 3. We'll go through this whole process. Excuse me, here. -4, -2, and that would be +8 and 0, which if it's an answer, if -4 is an answer, you'll get a 0 as your remainder always. So what's left then is 3x squared plus x minus 2. Now what they want us to do is finish solving here. It says solve the polynomial function. The previous examples, it just says to divide, so you just have to divide. Here we're just dividing. Here we're just proving that x minus 4 was a factor by dividing. But if you have to solve completely, that means you need to get all the answers. So there should be 3. We have 1, x minus 4. So there's 1. And what's left is 3x squared plus x minus 2 equals 0. So what's left is a new polynomial function, usually a quadratic, which we can solve using any method we want. Going back to Unit 3, you can factor if it's factorable. Completing the square, the quadratic formula always works. So just some options for you. Now this one is factorable, so I'm going to go ahead and factor it. So there's no greatest common factor because, yeah, we would have taken care of that already. So we're going to start by taking A times C, and we get 3 times -2 is -6. So I'm looking for factors of -6 that add up to 1. And hopefully you're just yelling very loudly at your screen right now that it is 3 and -2. Now because my A value is not 1, I do need the box here. So I'll go ahead and set that up. We'll go 3x squared and -2. So my first and my last term. And then we can go 3x and -2x there. And we're going to take out the greatest common factor. So starting up here, looks like I could take out a 3x. Down here, it looks like I could take out a -2. Going up the left column, it looks like just x. And going up the right side, it looks like just 1. Again, you can multiply this all back out and see if you did it right, which we did. I'm feeling pretty good about that. So we'll go x plus 1 from the top times 3x minus 2 from the side equals 0. Then we will take each factor, set it equal to 0. Hey, look, so we have one answer up here. We just got a second. And we're going to get a third here. So 3x minus 2 equals 0. 3x equals 2. X equals 2/3. And they're all three answers. And again, I knew that I had to do this all the way because it said to solve. I need all three answers. They gave me one, so that was pretty sweet. I just had to find the other two by first taking my cubic down to a quadratic, because we have 4 different ways to solve a quadratic. We only have one to solve a cubic. So here are a couple more examples for you. Just pick 2 out of the 3. I don't know that any one is going to be easier than the other. Example number 7 might be interesting to look at because it is a quartic. So you might actually have to divide twice, which leads us to a whole nother process, but just something to think about there. But yeah, pick 2 out of 3, and that is it.